I'm glad you said something. Well, here we go. Finally, we will start the quiz 3 preview. For each of the following, name the center line or vertical shift. I would just assume that you wrote the y equals line instead of writing up or down. It's fine. If you wrote both, that's fine, but just tell where the center line is, like I kind of did every time I wrote y equals and then the center line. The amplitude, the period, and the phase shift, then graph one period of the function described. Now, obviously, some of these won't be inclusive on that particular graph, so you can write none or whatever. Make sure you graph one period of the function and make sure to label 5 ordered pairs for that period. Okay. This is a cosine graph. It has a -4 for its A value. Now, that doesn't tell you what the amplitude is. It says A is -4, which means you're going to reflect. But the A value is not the amplitude. Do not write -4 for your amplitude. You need to take the absolute value of that. It is +4. All right, do not write -4. It will be marked wrong. The center line will just be the normal y equals 0. There's no vertical shift. The period for the regular cosine is 2 pi, and there is no phase shift. You can write NA or none. I don't really care that much about what you write there. Okay, so this, since it has a center line of 0, an amplitude of 4, and a period of 2 pi, on my y-axis, I need to have 0. I need to go up to 4. I'm just going to go ahead and put it at the top there. And since this looks pretty evenly marked as it is, I'll go down to -4 here. The graph needs to stay between the horizontal line y equals -4. So if you are having trouble staying within your lines, you could take a ruler and just quick dash this off. Do not spend an enormous amount of time on that though. Okay, then we need to mark the x-axis. We're going to go out to 2 pi. If you went all the way out to the end, that's fine. You don't have to. Don't go, trying to squeeze it all in here or something. That would just be hard for me to read, okay? So go somewhere out to the side that makes sense. Halfway would be pi. Half of that is pi over 2. 1 pi over 2, 2 pi over 2. Between pi and 2 pi would be 3 pi over 2. And then you would sketch your cosine graph, which is going to start reflected. So normally it would start up here at 0,4, but since it's reflected, it starts at 0, -4. Then it goes to the center line, and then it goes to the max at pi, back to the center line, and then down at the end of the graph at 2 pi. I need it to be curved. Okay, these are like quarter circles, if you will. I did a sloppy job on the end, so I just erased it just a second just to do a little better. You're allowed to erase, but I'm not going to get so picky that you're going to be in trouble if it's not perfect, obviously. Mine's not perfect either. All right, you need to label your 5 key points. This is at 0, -4. The second one's at pi over 2, 0. The third one's at pi, 4. Oh, I don't know why I made a slash between those. Pi, comma, 4. Made my comma too big. 3 pi over 2, 0, and then 2 pi, -4. Can I go a little faster than that if I do on the next one? All right, next one. No? Okay, center line or vertical shift it has moved. This is y equals 1 for the vertical shift. The amplitude, the A value, do we need a reminder of the format? Okay, A is 1, that's what's in front, or the coefficient there, amplitude of 1. There is a B value of 1, but the period did not change. It's just the normal period of 2 pi. This one has a phase shift, though, of right, and you do need to write right or left, and it's pi over 4 to the right. Okay, so since I'm sliding to the right, I will not want to go all the way to the end with my period. So I'm going to go to 2 pi about here. I'm going to cut that in half, pi, half of that, pi over 2. And then 1 pi over 2, 2 pi over 2, halfway between pi and 2 pi, 3 pi over 2. Trying to make my spacing as even as I can. Again, perfection isn't necessary, but it needs to be close, you know, relatively close. All right, so oh, wait a minute. That's on my x-axis, so that's where y is 0, but my center line is at 1. So I'm going to need to mark off 1, and then I could dash in that this is my center line if that makes you feel more comfortable with your graphing, and it does help you get things in the right place. And then going an amplitude of 1 above will put us about here at 2, trying to space it evenly vertically, and then down from the center line would be at 0 if you went down 1. So you're actually staying in between the x-axis and the horizontal line y is 2. All right, so now I'm going to quick graph. This is a sine. It would start at its center line. It does not reflect it, and it would go up. By the way, I'm doing the graph before the phase shift right now. You don't have to do this. So this does not have to be part of your answers tomorrow on your quiz. But this is what it would look like without a shift. And I didn't do perfect on my spacing, I can tell, because it's a little more stretched than that was. But anyway, close enough. So I'm going to now shift this thing pi over 4. Pi over 4 is half of pi over 2. So that means I need a mark halfway between 0 and 2 pi. That's going to be pi over 4. So what I'm going to do right now is make a mark halfway between every mark I have on here so far. And then I'm going to go 1 past it. And now I'm going to label them. So I've got 1 pi over 4. Everything's marked off in pi over 4s now. 1 pi over 4, 2 pi over 4, 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4. 6 pi over 4 is 3 pi over 2. 7 pi over 4. 8 pi over 4 would be 2 pi. And 9 pi over 4 would be my last point, is at the location of it. So I'm going to go ahead now and start at my center line. Go and shift all of these points over pi over 4. And then this would be, oops, this is your final answer. Okay, except we need now to label those points. This would be pi over 4, 1. I just wrote it up there. This one is 3 pi over 4, 2. And this one is 5 pi over 4, 1. 5 pi over 4. I don't know what I wrote pi very strange. Let me try to fix that. Okay. And then this one is at 7 pi over 4, 0. And the last one's at 9 pi over 4, 1. Okay, so those would be your 5 key points that you need labeled. And I probably could fix this thing up a little bit. Make it look a little better. All right, good enough. Number 3. This one does have a new period because there is a b value. This would be b. So the period is 2 pi over 3. I see no other numbers attached to this, so the center line would be y equals 0. The amplitude would be 1. There is no vertical shift. And there is no phase shift. So this just has a period of 2 pi over 3, and the amp is 1. So I'm going to, if you want to mark off 1 up here and just make a nice big graph, -1 down here. We're going to go out to 2 pi over 3. And then cutting 2 pi over 3 in half would be 1 pi over 3. Half of that, what's half of pi over 3? Okay, pi over 6. And then our scale is, x scale is pi over 6, so 1 pi over 6, 2 pi over 6. 3 pi over 6 would be pi over 2. Okay, I'm going to stay in between the max. If you want to dash that line out, you may. If you don't, don't. Okay, then if this is a cosine, so it would have started at the max, gone to the midline, or center line, down to its minimum, then back to the center line and back up. Oops, make this be curved. All right. And then label 0, 1, pi over 6, 0, pi over 3, negative 1, pi over 2, 0, and 2 pi over 3, 1. Okay, number 4. Anybody still need this? Okay. I slid this over, and there's a reason, because this has a shift, all right? The center line is y equals 1, and I might even extend that. So if you don't, I'll talk to you about this because this wasn't on your paper, correct? All right, the amplitude is 3. The period is 2 pi divided by, you don't have to write what you did to get it here, but I'm showing what I'm doing. 2 pi divided by the b value, which would be 2. The phase shift is left 2. Okay, so it's the opposite of what's here because it says plus 2 and it's supposed to say minus c. That would mean this is a shift left. So how am I supposed to go left 2 here if the period is 2? That would be impossible really to squeeze into this picture. So my apologies for not thinking about that before I ran this off and moving this stick. Okay, so on the quiz, they're all about the same, and I actually stick them in the middle so I know whether you knew it went left or right. You know what I'm saying? So if it's not going to give you a hint. You're going to have to know which way it's supposed to go. All right, so I'm just going to go ahead and stick in this. Well, actually, I'm going to slide that over it more in the middle from here to here because I really don't want this to be in my way. And that's not even very vertical, is it? Oh, well. Ew. Can I fix it? Come here. It doesn't want to be. Oh, good enough. I think this line's not horizontal. Whatever. It's not going to be perfection. All right. So I've got a center line changed to 1. So if I'm going to make that be 1, and that's got to be my center line, and I got to do a horizontal shift left 2. I need space over here. That's why I've put this here where it is. Now, the amplitude is 3. So if I made that be 1, then the next one is 2. I'm going to have to extend my little vertical line here. Do you have room to extend it a bit? Okay, there should be ample space on the quiz. 1, 2, and then I'd have to go 3, and then maybe up to 4, like that. I'm trying to space it a little evenly. All right, if that's my center line and my amplitude is 3, then I went up to 4 as my max. So that's going to be my guideline for the top of the graph. Oh, not so perfect, but whatever. All right, and then I have to go down from there, 1, 2, 3. So that's going to put me at -2 for a minimum. I don't know, I'm just putting in guidelines. Okay, now I'm going to have a period of 2, so I'm going to go out to 2 at the end here, and I'm going to do this graph as if it's not phase shifted. So this would be 1, and then half of 1 is 1/2. 1/2, 2 halves, half of that, 3 halves. And then if I didn't do a phase shift to the graph and it's a sine, then it would have started at its center line, gone up to its max, back to its center line, down to its min, and back to its center line. So this would be the dashed graph if you're planning to do one. And then the phase shift is left 2. So I'm just going to put -2 right there. Half of that, -1. Then this would be -1/2 and -3 halves. And then I'll just back the whole entire graph backwards. And it would look like this. Okay, so the first point here is at -2, 1. The second one's -3 halves, 4. The third one's -1, 1. The fourth one's at -1/2, -2. And the last one is at 0, 1. I didn't space this very well, but oh well, that's still going to be an acceptable looking graph. All right, that's it for graphing today. You will have 6 graphs on the quiz though. Okay, on the back, quiz preview, one thing we need to pay attention, a reminder that all of your reference angles make a what? We call it the bow tie. All right, so where they are, quadrant 1, theta is its own reference angle. In quadrant 2, the reference angle is here. Quadrant 3, it's always with the x-axis. Not that, I mean, I just wanted to remind you that. So I'm just going to quick write the answers to some of these, and then you tell me what ones you need me to go over. So the reference angle for 300 degrees is 60. The reference angle for 2 pi over 3 is pi over 3. Reference angle for negative 120 is 60, and for negative 5 pi over 4, it's pi over 4. Does anybody need to talk about how I got those? Because I can draw them for you. Yes. Yes, they are always a positive angle with the x-axis. Never negative. Does anybody need me to explain any of those? I don't care if you need these, anything you need, you got to just, otherwise I'll spend more time on something else. We understand the radian ones? This is 45, and that's 60. Do you know where you are if you're here? Does it really matter? Not really. You still got to get back to the x-axis by going pi over 4 units. Okay, then I'll go to the next section. Convert each, I don't know why this is crooked, but anyway, convert each degree measure into radians and each radian to degrees. Multiply by pi over 180 for that one. Multiply by 180 over pi for this one. Your answer for number 9 should be 3 pi over 4, and number 10, 315 degrees. All right. Honestly, I should be putting something on the quiz that you can't find on your unit circle. It could very well be not something on your unit circle. So you better know how to do the conversion. Well, obviously, if you're going to get to use that green sheet, you sure could look. Yes. This. You do what? Yep. And then hit math, enter, enter. In this one, you just cancel out the pi's. Do 7 times 180 divided by 4. Okay. All right. Find the exact value of each trigonometric function. Well, notice that these aren't necessarily on your unit circle because they're not, most of these are negative or something. Now, I can explain how to get these using the unit circle. I can talk to you about where these are if you need me to. Let me know what you need. So the sign of negative 135, I'll just describe where it is, would be negative 135 would be here. The sign is negative in quadrant 3, so this would be negative square root of 3, excuse me, square root of 2 over 2. All right. Any more needed on 11? Okay, 12. Secant of negative 300. What I would think about is what is the cosine at negative 300? Okay, so you want to think about where that might be. Positive 300 is in quadrant 4. Negative 300 is in quadrant 1. No, it'll be 1. Negative 270 is here. Negative 180, negative 270, negative 300 would be in here. Cosine is positive in quadrant 1. That is a reference angle of 60. So, at what is the cosine at 60? It's 1/2. So, this would be 1/2. This is 1/2. So, then you would do the what? The reciprocal. So, you'd flip over 1/2, and the answer is 2. Yes. You'll have that green piece of paper. All right, cosecant 150. You want to be thinking about what's the sign at 150. So in quadrant 2, you would be terminating. The reference would be 30 degrees. The cosine at reference of 30 degrees is the square root of 3 over 2, right? Wait, this is number 13. No. You're supposed to be thinking about the sine, not the cosine. And I forgot what I was reading there. It says cosecant, not cosine. Okay, so I want to think about the sine at 150. The sine at the reference of 30 degrees is 1/2, so this would be 2. And sine is positive in quadrant 2, so I know it's positive 2. Okay, this is 1/2. This would be 2. So the answer is 2. Are we good? All right, tangent at negative 120. Negative 120 would be in quadrant 3. Tangent is positive in quadrant 3. That would be a reference to 60 degrees. If you want to think about the special right triangles, you could. This would be negative 1, and this would be negative square root of 3, and the tangent is y over x, so it would be square root of 3. The other way you can do it is if you're looking at your unit circle. Does anybody want me to explain it differently? Because I can. Okay. If you were at your unit circle at that point, this would be the point. Where we at? Reference of 60, so that's negative 1/2, negative square root of 3 over 2, right? That's your point at that angle. All right, so then you'd say the sine over the cosine, or the y over x. So if you did the negative square root of 3 over 2 divided by negative 1/2, you would change that to square root of 3 over 2 times the reciprocal of 1/2 is 2. And that gives you the square root of 3. Okay, so you can do it that way, or you can do it with special right triangles. Number 15, the sine of negative 330. Negative 330 is going to be in quadrant 1. The reference would be 30 degrees. So if you're looking at 30 degrees, the sine is 1/2, and this is positive, so it'll be 1/2. And that was number 15. Okay, number 16 at 3 pi over 2. If you're doing the tangent, think about where that is. 3 pi over 2 is here. The point for 3 pi over 2 is 0, negative 1. The tangent here is, well, tangent is y over x, and so that would be negative 1 divided by 0, which is undefined. Okay. 17, negative pi over 3, just so you know where that is. It's quadrant 4. The point there, I'll explain it with the point using the unit circle. At negative pi over 3, aren't we at positive 1/2, negative square root of 3 over 2? Right? You guys got a unit circle to look at. I'm trying to, I have memorizing. Okay, so, no, yeah, that's right. Okay, so then the tangent is y over x, so it's negative square root of 3 over 2 divided by 1/2. You multiply by the reciprocal of 1/2, and you get negative square root of 3. Number 18, cosine of negative 3 pi over 2. Positive 3 pi over 2 is here. So negative 3 pi over 2 is up there. Okay, that's the point 0, 1. Cosine is 0. And 19, cotangent of pi over 2. So I go, where's pi over 2? Well, that's right here. That was where I was just a moment ago. 0, 1. Cotangent is x over y, so it would be 0. And maybe you remember tangent is y over x. So if you memorize that, then just flip that over, would be x over y. 0, no matter what I do. 315 would be in quadrant 4. The reference angle is 45 degrees. So if you want the cosine of 45, cosine's positive in quadrant 4, the cosine square root of 2 over 2. Okay, does anybody want anything else or more explanation on any of those up through 20? Okay. Yep. They're all written cosine sine. State what quadrant you're in if the tangent of x is positive and the cotangent is negative. Cosine is negative in quadrants 2 and 3. Where's the tangent? Positive. 1 and 3. So it'd have to be 3. Find a value of x where this is true. If sine is 1/2. So you're looking for any point where there's a 1/2 in the second position. So you have that answer in quadrant 1, which would be at pi over 6. Okay, right, pi over 6. This is a reference to 30. It's the first one in the quadrant 1. Now, where else do you have a positive 1/2 for the sine? That would be at 5 pi over 6. Now, why did I write those in radians? Well, because you could. If your direction said for x between 0 and 2 pi, and you'll need to know this in your next, and if you take trig next year or pre-calculus, if x is, the directions say x is between 0 and 2 pi, you would give radian answers. Did I have to give radian answers here? Not really, because it didn't specify. If it said for x between 0 and 360, you would give degree answers. What are these in degree? 30 degrees and 150. Okay, so actually the answers could be 30 and 150 or 5 pi over 6 and 5 pi over 6. Do we need more clarification on this? Sine is the second part of the point. All of a sudden my blower went off and it got really quiet in here. So I felt like I was yelling now. If I talked that loud as I was a moment ago, I'll feel like I'm really yelling. All right, using radians, find the amplitude and period of each function. The amplitude would be 1/9. The period would be 2 pi divided by 4, which is pi over 2. All right, number 24, amplitude is 4, period is 2 pi over 7. Number 5, amplitude is 8, the period is pi. And number 26, the amplitude is 5 and the period is 2 pi over 3. All right, that is the end of the quiz preview. I'm going to pause a moment and open up worksheet 27B. Okay, we went through these already and decided whether they were coterminal or not. Remember, you just add or subtract 360 to find out if they terminate in the same place. Okay, so that's all we did. Those are the answers for 1 through 10. So if you were watching the video, you would know the answers. There you go. Boom. All right, what about this stuff? You know where you are if you're at 3, -4? Let's hope. Okay, what do you do to figure the rest of the trig, all these trig functions out? Okay, so then you say that x is 3, y is -4. What's the radius, or r? So you need to remember that x squared plus y squared equals r squared, just like a circle. Okay, so that'd be 3 squared plus -4 squared equals r squared. That's 25, and then you take the square root and you get r is 5. So this would be 5. And then you could write all the trig functions of theta. It said to calculate the sine, cosine, and tangent ratios. So the sine of theta would be -4 over 5. The cosine of theta would be 3 over 5. And the tangent of theta would be -4 over 3. Bless you. Is there any particular one here you'd like me to do besides that one? It's like 6 minutes. Okay, so x is -5, so you guys know what to do. Y is -12. R is, in this case, would be 13, if you did the Pythagorean theorem. 5 now. All right, you don't need me to go over any more of these? Then I won't. All right, somebody asked, so I could do a couple more. All right, this section, if to find the remaining basic trig functions of theta, assume theta is positive and in standard position. What does sine of theta being 3/5 tell you? And you're in quadrant 1, so that tells you a couple of things. If the sine is 3/5, that means the y is 3 and the r is 5. So this tells you that y is 3, r is 5. And then you figure out x, and it would be 4 because I know special 3, 4, 5 right triangle. So I found out x is 4, and then you would write the remaining basic trigonometric functions of theta. I would think they want me to tell you that the cosecant is 5/3. Oops, I should have put a theta there. And you could do the tangent, you could do the cotangent, etc. I keep dropping letters when I'm writing here. I'm just trying to go fast. Tangent is y over x, so 3/4. Cotangent would be 4/3. The cosecant would be 3/5, and the secant would be 5/3. I just did that something upside down. I wrote this cosecant twice, and I screwed up one of them, didn't I? I forgot to write cosine. Let me fix that. Going a little fast here. The cosine would be 4/5. Let me just at least give an answer of cosine. And the cosecant would be, oopsie, secant was 5/4. I really messed that up. What's the cosecant? It would be 5/3. How did I do that? I have no idea. Okay, those are the correct answers now. Are we good? All right. Now, what about if tangent's 1 and you're in quadrant 1? You know what to do? If the tangent's 1, it said, oh, not in quadrant 1. Ooh. Then it has to be in quadrant 3 for it to be positive 1, which means the sine and cosine are negative. Okay, what's the reference angle if you have a tangent of 1? Okay, if you don't know that, you are missing a huge idea. 45. Why? Because that's the only place where the sine and the cosine are the same, guys. Tangent is y over x. Same thing over same thing. It has to be 45. Okay, so that means that the cosine theta would be negative square root of 2 over 2. The sine of theta would be negative square root of 2 over 2. Okay, the cosecant is negative square root of 2, and the secant's also negative square root of 2. Cotangent is just 1. There's still 2 minutes before the bell. Could you please stay still? Thank you. Do we have one more thing? Quim? Could be. I'm not going to say no. So, like, do we need to know this? You sure do. Oh, okay, sweetie. Tell me where you're, is it this one in particular? Yeah. The only thing I would worry about is this is on the unit circle, so it's part of like using the unit circle even. It was actually before that though. So it's on the unit test. So I'm not going to say there's nothing at all like it, okay, but it's not a huge focus.